Okay, we are ready to move on in 2.5. If you recall from the first video, we just spent some time looking at these basic functions because the rest of this section, and as you go through the homework, you're going to be taking these basic functions and then applying some transformations to them and moving them, shifting them to the right, left, up, down, making them narrower, wider, or even flipping them upside down. So let's just jump right in and look at what's happening here. So for all of this section, I am going to be using Desmos, which is a website that I've introduced you to before. And so I'm not always going to come back and fill in the blanks here, but we will do that verbally as we go. And so anytime you want to pause or if you need to go back, feel free to do that. We are just going to walk through all of these and look at all of these different graphs of what happens when you do different things to the equation. So follow along in your notes, but I'm going to be over on the Desmos website. Looks like I need to clear out some stuff I was playing with a few minutes ago. And also, if you want to pull up this website, this is a really fun tool that will help you really visualize what is happening to these graphs. So rather than plot points, this is nice. You can also do these on your graphing calculator as well. But I do think the interface with this website is so much better. So as we look at the bottom of page 1, let's just read the directions, then we'll do it in Desmos, and then we'll answer the questions about what we see. Sound good? Okay, sketch the graph of y equals x squared plus 5 and compare it to the graph of y equals x squared. So again, you could do these on your graphing calculator. I'm going to use Desmos. So there's my first one. I love how it just looks the way it should. The x squared looks like x squared. A very easy input. I did use the caret that is above the 6 on my keyboard to put the x squared. Oops. X squared. Okay, so there's my two graphs. It has two different colors, so that makes it really easy to match up which is which. So the green one, which is the one that's above, is x squared plus 5, and then the one that is purple that goes through the origin, you can see it right down there at 0, 0, is the y equals x squared. So that's my basic one. If you go back to the top of page 1, that second graph is that basic parabola, y equals x squared. There it is. It's the same one. But then we have the second one, which is the green one, that is raised up. Now, let's just take a look. How far is it raised up? Here is the number 2. And so that means every one of these units, or every one of these hashes, these grids, is a half. So 2, 4, there's 6, so halfway in between would be 5. So is that a coincidence, do you think, that our equation had a 5 in it? It actually is not. So before you graph it, and before I do, I want you to read this next question. What do you think y equals x squared minus 5 would look like? Based on what we've learned here, what do you think it'll look like? It's still going to be a parabola, because I told you before in the last video that if you have that x squared, if that's your highest power, you're going to have a parabola. What do you think our graph is going to look like if it's y equals x squared minus 5? So write down your answer. You can write a sentence or you can sketch it. You've got the graph there. Sketch what you think it's going to look like and pause. And then when you're ready, go ahead and move on. I'm going to put it on my graph. Okay, were you right? Was that what you expected? You see the black line? It is the same shape as the others. They look like they're inside because they're nested. If I back up, they are the same shape. It's just shifted down, and it's right in between the 4 and the 6, so it's at negative 5. So was that what you were expecting? I'm guessing it probably was. If you thought about this one went up 5, this one went down 5. So now we can make a general rule, and you're going to need to remember these or know how to find them, because as you go through the homework and as we work on this chapter, you're going to sometimes have to apply more than one of these to a function, or say what the equation would look like if one of these transformations happened. So The definition, this is called a vertical transformation. So anytime you have the graph, nothing else changes, it just moves up or down. It's a vertical translation. So that's what goes in the first blank. And then if we have y equals f of x plus b, so we're starting with the function f of x. If we add b, and notice right above that it says b is a positive number, b is greater than 0. If we add a positive number, what's going to happen to that graph? It's going to move up b units. So whatever b is, in our case it was 5. We added 5 to the end. It moved up 5. And the second rule here, y equals f of x minus b. If we subtract b, subtract some positive number, it's going to move down. So we can actually do the same thing with any of those graphs that are at the top of page 1. So let's just go up and grab a different one. Let's do the y equals 1 over x. Okay, so there's the graph. Let me get this centered a little bit more. Do you see how that looks like the one? This is the second row, second one over of our basic graphs. So it looks just like it does in the picture, right? So what do you think would happen? First of all, how do we apply this? Y equals f of x plus b means that we're going to add it after that fraction. So we would have something like y equals 1 over x. Let's just pick a number. Let's say, what would happen if I put minus 3 there? So y equals 1 over x minus 3. So pause this and jot down what that answer to that question is, and then continue and we'll look at that. Y equals 1 over x minus 3. Okay, did it do what you expected it to do? Notice it still hugs the y. We talked about this in the first video about how this they get closer and closer to the y-axis but never touching it. But it no longer gets real close to the x-axis. It's down here at what we'd expect, -3. So as we go to the right, it comes down closer to -3 from the top, and to the left, it gets closer to -3 from the bottom. And you can keep playing around with this. If you have Desmos open, just play around. Keep adding different numbers to the bottom. Every time you add a positive number, and again, this is outside of, you're leaving that 1 over x the same. You're adding or subtracting a constant at the end. It's going to move it up and down, and you can just shift it around and see what happens if you change that number. There I added 10, so it moved the whole thing up 10 for that blue graph. Okay, let's go on to the second page. So we're going to do a different transformation. So again, I'm going to do what it says at the beginning, sketch the graph of y equals x plus 5. Notice it's all in parentheses squared, so the 5 is in there with the x, and compare that to y equals x squared. Okay, so there's our two graphs. The first one is the purple one. That's the one that has the plus 5. And then the black one is our basic function, which again matches what's at the top of page 1. So what do you say? What happens when you have that plus 5? Now notice instead of, in our first example, we added 5 to the end. It was completely separate. This is in with the x. So there is a big difference here because what happened? It shifted it to the left. Instead of it moving up like it did when we put the plus 5 at the end, it shifted it to the left. Interestingly enough, it shifted it in the negative direction. So when we had a plus 5, it shifted it to -5. The vertex or the bottom of that parabola is now at -5 instead of at the origin 0, 0. So question is, what do you think will happen if we do y equals and then x minus 5 in parentheses squared? So pause, think about that, write your answer, and then start back up. Okay, did it do what you expected it to do? I'm guessing yes, because basically when we had plus 5, it moved it to the left. So you would expect it to do the opposite. When you do -5, it puts it to the right. This one, it's kind of tricky because you kind of expect it to do the opposite. Okay, so let's fill in the blanks under this. This transformation is called a horizontal translation. So, and that kind of makes sense. We're moving it to the left and the right. So for when d is greater than 0, so a positive number, and notice how this is written, y equals f of x plus d with the x plus d in parentheses, because whatever that number is, you're adding it to x before you do anything else, before you square it or whatever else is happening in this equation. F of x plus d, it shifts it to the left. Again, this is a positive d. When you add something, it shifts it to the left. And the second line, y equals f of x minus d. Again, that whole quantity is in parentheses, so that means whatever you're doing to x, you do to x minus d. It shifts it to the right, which is what we saw for the red one. Okay, we good? Okay, let's move on. I'm going to go ahead and leave y equals x squared up there because we're going to continue to use that. So now it says sketch the graph of y equals negative x squared and compare it. What do you think is going to happen? Pause and think about it. Write down what you think is going to happen. Maybe even plot a point or two just so it makes sense. What would happen when we change it from y equals x squared to y equals negative x squared? Okay, were you right? Basically, we now have a parabola that opens down, whereas the original one opened up. So going forward, you're going to understand a lot more about whenever you see an equation, what's happening. Anytime that leading x squared, if you have a quadratic, it starts with an x squared. If it has a negative in front of it, it's going to open down. So whatever the sign of the x squared term, that tells you whether it's open up or opens down. And oh, this is called, so filling in the blank, this is called a reflection, which makes sense. It's reflecting it across that x-axis, like there's a mirror that's pulling it down to the x-axis. And then there's no fill in the blanks here, but y equals negative f of x is a reflection across the x-axis. Now we didn't do this. Y equals f of negative x is a reflection off the y-axis. In this particular case, if we replace the x with a negative x, okay, so that would be the second line there, y equals f of negative x. You're squaring negative x instead of x. What happens there? What is negative x squared? It's negative x times negative x. It's x squared. So that's going to be the same thing as y equals x squared. And you can see that black line where y equals x squared just turned green because it overlaid that over the original graph. So in this particular case, the f of negative x is the same as f of x. That's not always true, but in this case it is. Okay, turning to page 3. So you should be at the top of page 3. And again, I'm not flipping back and forth because there's not a lot to fill in other than sketching the graphs, filling in the blanks. So as we go, sketch, fill in the blanks. You can pause if you need to. Okay, page 3, sketch the graph of y equals 3x squared and y equals 1/3 x squared. I'm going to leave x squared up here as well. Oh, it does say compare to the graph y equals x squared. I was going to say I want to compare to that. I don't want to just compare these two. 3x squared. Okay. So what happened there? The purple line, it kind of brought everything in. It narrowed it, didn't it? Made it a narrower parabola. And now let's do the second one. Y equals 1/3 x squared. So both of, and there's that, I don't know why it made it black. Let me change the color so it contrasts a little more. Oh, maybe I can't. I thought I'd be able to change the color. Okay. Okay, to change the color, you don't just click on the color in front. So just in case that hides it. If you want to change the color, you actually need to set this click this little gear to change the settings. And then you can click on the color in front of it and change it to whatever color you want. So in this case, I had two of them that just by default came in as black. I needed to be able to tell them apart. So now we have the red parabola that is out here. It is the widest one, but it has the smallest number out in front, right? And then the purple one is really narrow, but it has a larger number out in front with the 3. And you can play around with this. Keep playing around. Try different numbers. Of course, if 1 is the number out in front, it's going to just be 1x squared, which is going to be our black line. You know, try 2, try 4, try 1.1, and just see what kind of pattern you can find. That one's just slightly bigger than 1, so you can see the purple and the black are really close together. And what you're going to find is as your number gets bigger, it gets narrower. And let's just think about why that would be. Let me change that back to a 3 so it matches your page. Oops, deleted the wrong one, but that's okay. So this purple one, let's just plot a point. When we were plotting before, we plotted 1, 1. 2 squared is 4, so you can see that on the black line. Now what if it's 3 times x squared? When we plot x, we get 1 squared is 1, but times 3. Do you see how that just lifts those points up? 2 squared is 4, but then we have to take it times 3, so we go all the way up here to 12. Does that make sense? And in fact, Desmos is kind of nice. You can click spots. Okay, so there's 2, 12, and then down here was 1 times 3, which is 3. Getting close on those. Okay, and then on the other one, the opposite is happening. When you take 1 times 1, 1 squared is 1, but then take that times a third, you see how we're 1/3 of the way up to 1. That's just a fraction, 1/3. 2 squared is 4, so on the black line we're up here at 4, but take a third of that, you get 4/3 or 1 1/3, which is right here. So those smaller numbers, those numbers that are less than 1, make it wider, or you can think of it as bringing the arms of the parabola down. The numbers that are bigger than 1 are making the parabola narrower, or in other words, bringing those arms up because we're taking them times the number, so it's making them taller. Okay, let's look over at our worksheet. Hopefully you have this handy and printed it out, and you sketch the graphs so you have a pretty good feel for what happens when you put a number in front of the function. And this is going to be true for those others as well. If you put a number in front of, for example, absolute value of x or any of those other functions that were on the first page, same thing's going to happen with the number that's bigger than 1. It's going to make it narrower or taller. The numbers that are between 0 and 1 are going to stretch it out. We're not dealing with negatives because the same thing is going to happen if the numbers are negative. In fact, before we fill in the stuff at the bottom, let's look at some negative numbers on Desmos. Here I have the y equals 3x squared. We've already looked at that one and compared it to x squared and 1/3 x. If I just change that to a negative, it has exactly the same shape, but it opens downward. So we don't have to have a separate rule for numbers less than 0. Instead, the way we're writing the rule is we're going to talk about absolute values. So when we take the absolute value of that number, is it bigger than 1 or is it less than 1? If it's bigger than 1, it's going to stretch it vertically. And if it's less than 1, it's going to shrink it, which makes it that wider, like our 1/3 one. So here's our rule, and this is called vertical stretching and shrinking. So the word that you need to put in the blank there is vertical. Okay, let's move on to the next section. In our notes, it's right here. We're going to look at y equals, now what's the difference between this and what was at the top of the page? It looks pretty similar. Do you see the difference? Here we have 3 out in front being multiplied by x squared. In this one, the 3 is being multiplied by x, and then the whole thing is going to be squared. Okay, so that's the distinction here between those. So let's just change this to have those parentheses around the 3x. And then we'll do the same thing. Let me add my y equals x squared as my base that we want to compare it to. And then y equals, and then in parentheses, 1/3 x. The whole thing squared. And I want to change colors again. I want these to look different so I can see them apart. Okay, so my base one is the red. That's my y equals x squared. So what happened here? They just got even narrower and even wider. And if you think about it, this makes sense. What happens if you multiply this out? Let me go over to our notes and let's actually multiply this out. If we have I'll do it up here. Y, oops, still on eraser, change to the pen. Y equals 3x, the whole thing being squared. So we're taking 3x times 3x. 3 times 3 is 9. X times x is x squared. So it makes sense that this would be even narrower than 3x squared, right? Because it's really 9x squared when we multiply it out. Does that make sense? I'm just going to graph y equals 9x squared. And what you notice there is that purple line went away because this black one is right exactly on top of it. Because when you multiply it out. So it makes sense that this would be wider than y equals 3x squared, because we said when we put a number that's bigger than 1 in front of the x squared, it just keeps getting narrower and narrower depending on how big that number is. So we've changed the 3 to now a 9 by putting it inside the parentheses. Does that make sense? And so what we call this is horizontal stretching and shrinking, and it's because it's just a small distinction of stretching it up versus pressing it in from the sides. So since this, in this case, the 3 is tied to the x, do you see how it's tied to the x? It's in the parentheses with the x. We think of it as that parabola being pressed from the sides and shrinking as it gets pressed from the sides. Instead of thinking of stretching it upward, it's pressing in. So this is horizontal stretching and shrinking. And if that number that is inside the parentheses with the x is absolute value bigger than 1, it's going to shrink it horizontally, so it's making it narrower horizontally. If that number is between 0 and 1, it's a fraction, it's going to stretch it out. And we didn't do that one. Yeah, we did. Here it is. And so again, if we multiplied that out, that would be the same as y equals 1/9 x squared. And so you can see that that's going to stretch it out even wider than the y equals 1/3 x squared that we did on the top of the page. Okay. We've got a couple of them that are black. It makes it kind of hard to distinguish them. There we go. No, now I have 2 reds. Oh well, we had that one there before. Okay, so hopefully this is kind of fun. I really challenge you. Open up Desmos, play around with this, punch some different numbers in. Of course, when you're doing your homework, you are free to use a program like this. I think it's very helpful to see it visually. Just keep in mind that when you get to a quiz or test, you are not allowed to use any external programs. You'll have to be able to do this on your calculator. And everything we've done in Desmos today, you could do on your calculator. I just think this visually is just so much nicer because of the colors, because of the white background. It's just much easier to see. But you could have done this whole lesson on your calculator. So when you're doing your homework, keep that in mind. You might want to use your calculator, but you're welcome to pull up a program like this if that helps you